Hello, this lesson is going to be on rational functions. Okay, a rational expression is an expression written as a fraction. So anytime you see the word rational or ratio, you think about a fraction. So here's some examples of rational expressions. And one thing that you want to remember about rational expressions is that you want to make sure the denominator is not equal 0. Okay, because anything that is divided by 0 becomes undefined, and we don't want our functions to be undefined. Okay, now this lesson today is going to be divided into 3 parts. This is going to be the first part, and the first part is going to talk about finding the domain. And finding the domain, we have to really think about this here right now, because you want to make sure the denominator cannot be 0. So when you're finding the domain, you look for the values of x that make the denominator equal 0. Or in other words, that makes the function undefined. So let's look at this example. I have f of x equals 2x minus 1 over x minus 3. My goal is to find the domain, and that means I look for values of x that will make the denominator equal 0. So in other words, I want to make sure that this denominator never becomes 0. So I want the denominator to be different than 0. That's the symbol for different. Okay? So it's just like an equation. We're trying to solve for x. So in order to solve for x, we're going to send the 3 to the other side. So that way, this will becomes x different than 3. So in other words, the value of x can be any value except for the value of 3. Because if I put a 3 right there, 3 minus 3 becomes a 0, and this function then becomes undefined. So in other words, the x can be any value like 2.5, 5,000, 500, but the only value cannot equal to will be the value of 3. Alright, how do I write my domain? I'm going to write in formal notation. So you write the letter D, you open curly brackets, put the letter x, put a little bar like this, that means such that, so x, such that x belongs to all real numbers. So this is the symbol for belongs to, this is the symbol for all real numbers, and I'm going to put the restriction. The restriction is x cannot equal 3. And we close the bracket, the curly bracket. Alright, so this is our domain. Means x such that x belongs to all real numbers and x different than 3. So in other words, this is saying that x can be any values in the real numbers, but with the exception of number 3. Okay, let's go to letter B. H of x. Okay, if you notice, the denominator is only the number 3. So the x has no impact on what happens to the denominator. So in other words, will there be any chance the denominator will ever become a 0? And the answer is no. So in other words, x can be any value. So my domain will be x such that x belongs to all real numbers. And that's it. There's no restrictions. X can be any value on the real numbers. So we're done. Okay, let's go on to the next problem. Okay, now the next problem, I had some old forms that had a little mistake. So you maybe have one of those old forms. So if this number is not 20, please cross it out and put a 20. You might have the new forms, which the correction already have been made. So it all depends what you have. But let's consider this function right here. Okay, and here I have a denominator, and I want to find the domain. So I want to make sure that the denominator is not equal 0. So this is a trinomial, so I'm going to try to factor. Well, is there any number that goes into all these 3 numbers? That's the first question I should ask. Is there any number that goes into all 3 numbers here, or 3 terms? The answer is no. Okay, second question. Is there any special factors that I can use here? Well, this is a perfect square, and so is this one. Maybe there's a chance that we can use a special factor, so let's try. Let's use 2, open 2 sets of parentheses, And remember, to fill in this parenthesis, I take the square root of the first, so this would be 2x, and the square root of the last, which would be 5. Alright, very well. And then we check. 2 times 2 times 5 is 20x. So that means I can use that special factor that says you take the first term over here, put it there, take the second term, put it there, raised to the square, and the sign here depends on the middle term, which, because it's negative, this would be a negative. Now remember, we want to set this different than 0. Okay. Now we want to solve this for 0. So we're going to do 2x minus 5 must be different than 0. If you notice, we don't care about the square here. We're just going to solve for x. So this would be 2x equals positive 5. We divide it by 2. X must be different than 5 over 2. Okay. So in other words, what is my domain? My domain is x such that x belongs to all real numbers and x must be different than 5 over 2. So that will be my domain right there. Very good. Alright. I just wanted to clarify here, before moving on, why I was able to do this here and get rid of this square. Because in reality, this here is 2x minus 5, 2x minus 5. Right? And basically, if you remember, we split this as 2x minus 5 different than 0, 2x minus 5 different than 0. But if you notice, am I going to get the same answer here as well as over here? Yes, I will, because they're both the same. So for that reason, we really don't care about the square here, because, I mean, yes, you have two answers, but the two answers are going to be the same answers. Okay? So anytime you see a square there, we can say the square goes away, and then you're left with 2x minus 5 different than 0. So I just want to make sure that you clarify that. So now we're ready to move on to the next one. The next one is letter D. H of x equals 2 over x squared minus 1. And as always, we want to make sure the denominator is different than 0. First thing I ask, can I factor anything from both terms? The answer is no. Can I use special factors? Well, I have perfect squares. So guess what? I can. This becomes x minus 1 and x plus 1 different than 0. So if I solve this, this would be x minus 1 different than 0, and this here will be x plus 1 different than 0. So this will become x must be different than, if I move the negative 1 to the other side, it becomes positive 1. And if I move this 1, it will be x different than negative 1. So how do I write my domain? My domain will be x such that x belongs to all real numbers and x must be different than positive or negative 1. And there's our domain. Very well. There we go. Alright, let's go on to the next one. This next one is going to be letter E. Okay. Again, I have a trinomial for the denominator, so I want to make sure that that's different than 0. I ask myself, can I factor anything from all three? No, I cannot. So, can I use special factors? I don't have any perfect squares, so no, I cannot use special factors. So, basically, I'm going to have to take the first term and the last term, come here to the side and multiply. 3 times 2 equals 6. Create a list of numbers that gives me 6. So 1 and 6, 2 and 3. And that's it. Now look at the sign of the middle term. The sign is a negative, so that means Actually, first of all, look at the middle term is a 5 and determine which one will give me a 5. 2 and 3 will give me a 5. 6 and 1 will give me a 5 because 2 plus 3 is 5 and 6 minus 1 is 5. Now you look for the sign. The sign of the middle term is negative, so that means the biggest digit is going to be negative. And if this is a negative 3 and I want to get a negative 5, then the 2 has to be a negative. And on the case of the 1 would have to be a positive because negative 6 plus 1 gives me a negative 5. Now the question is, which one of these, when I multiply the signs, will give me a positive? Well, a negative times a negative gives you a positive. But a positive times a negative does not give you a positive, so you know that this option fails. So we know that this is our answer. So we're going to bring it down, the 3x squared. We're going to split the 5x as negative 2x minus 3x plus 2, different than 0. And now we're going to group them in pairs. So this will be, what can I factor from the first two? I can factor out an x. So this would be 3x minus 2. Bring down the negative. What can I factor from these two? A 1. So this will become 3x minus 2, different than 0. Alright, now I have two terms. What do they have in common? They have in common 3x minus 2. And if I remove the 3x minus 2, what I'm left with? X minus 1. Alright, this one, I'm going to do 3x minus 2 must be different than 0. I'm going to move the 2 to the other side, so it'll be 3x must be different than 2. I'm going to divide both sides by 3. So that means x must be different than 2/3. Alright. Then we're going to do the same thing over here. X minus 1 must be different than 0. And x must be different than 1. Alright. So now let's write our domain. Domain is x such that x belongs to all real numbers and x must be different than 2/3. And I'm running out of space here, so I'm going to write up underneath x different than 1. So this is going to be my domain. Okay. Alright, very well. Let's go on to the next one. Okay, this one, we can take this guy right here, and we want to set it to different than 0. Okay, and we ask ourselves, can I factor anything from both of them? The answer is no. Is there any special factors that I can use here? No, because this is a positive. We don't have a special factor if it was a negative. Also, if you notice, 2 is not a perfect square, so no. So can I factor this? The answer is no. Also, if I try to solve for x squared, this is like a little preview of what's coming next for radical equations. Basically, you're going to try to get the x squared alone. So basically, you're going to send the 2 to the other side. So it becomes a negative 2. To get the x alone, you're going to try to do a square root on both sides. And the thing is, square root of negative number is not possible. Or, in fact, what you're going to get is what's called an imaginary number. So basically, the negative comes out of the radical as a letter I, and there's no square root of 2. So the answer would be this, I is square root of 2. And because this is not a real number, then we say that x such that x such that here's wrong. The domain equals x such that x belongs to all real numbers and there's no restriction. Okay, so basically, if you cannot factor in a problem like this, you would write x belongs to all real numbers because you cannot factor. Okay? Alright, so let me try to say this again, because I know some of you might have some questions here. Basically here, can I factor this? No. Is there any special factors? No. Can I factor? No. So then basically you just write domain equals x such that x belongs to all real numbers. Okay? Alright. Now, what I was trying to say is there a solution for this problem? Yes, there is. But it's not going to be a real number. It's what's called imaginary number, and it's something that we're going to learn later on in the course. Okay? But so, for now, this concludes part 1 of the lesson on rational functions. Thank you very much for your time, and I look forward for part number 2. Okay? Thank you. Bye.